Welcome to the HPE Slingshot monitoring software demo. Here, we will showcase how system administrators can efficiently monitor their Slingshot system and how the HPE Slingshot monitoring software can be used to troubleshoot the fabric and performance issues. Our key stakeholder is the system administrator, whose goal is to scan the fabric at the start of the week, identify anomalies, and resolve issues. On Friday, the fabric was in an optimal state. However, during a Monday morning sweep, the administrator notices a slight spike in link issues on the Fabric Overview dashboard. Using HPE Slingshot monitoring software, they investigate and discover link flaps occurring on one of the ports. The administrator drills down into the suspect switches and ports and applies the recommended reconciliation actions to restore stability. Let's assume the system admin is already logged into the system and viewing the high-level Fabric Overview landing page. During a Monday morning health check, they notice an uptick in link issues. The panel shows 5 unhealthy links and an unusually high number of unhealthy switches, which is not typical for the system. To investigate further, the admin quickly drills down into the switch overview by clicking on the total number of unhealthy switches, aiming to understand which switches and groups are affected. Once redirected to the switches overview, the system admin is presented with a quick summary of switch health in a topological group-centric view. Each label 0, 1, 2, etc. represents a topological group, and within each group are individual switches. These squares are color-coded and shaped according to their health status of each switch, as shown in the legend below, making it easy to visually scan for issues. Supporting this visual layout is a detailed filterable table that includes key information, such as switch names, IP addresses, status, ASIC temperature, severity level, firmware version, uptime, and group/switch IDs. This combination of visual and tabular data provides a high-level summary that helps the system admin quickly pinpoint which switches need attention. In this scenario, the Fabric Overview page previously indicated that 17 switches were unhealthy. Now, with the topological and tabular views, the admin can identify exactly which switches are affected and where they are located within their groups. They begin troubleshooting with this switch highlighted in red. Clicking on this switch takes them to the switch drill-down view, where more detailed diagnostics are available. On the switch drill-down view, the system administrator gains access to critical information for diagnosing an unhealthy switch. At the top, they can see key details such as the switch model, firmware version, IP address, and uptime. This view also introduces a switch port display, which mirrors the physical layout of the switch ports and shows local, global, and edge ports in both graphical and tabular formats. Hovering over any port icon reveals a tooltip with additional details. Clicking expands and collapses it. This switch port display can also be transitioned to a filterable table by clicking the table button here. Selecting a port's X-name navigates directly to the link detailed view for that port. At a glance, many global and local ports are flagged in red. These details matter because port roles indicate connectivity scope, whether issues are isolated or widespread. Uptime helps identify recent reboots or instability, while firmware version highlights potential compatibility problems or missing fixes. Together, these insights provide a clear picture of switch health. Below the port display, a time series visualization shows errors and alerts, color-coded by category. At the bottom, tables list Fabric health alerts, HSN link events, and redfish alerts, with details such as timestamp, event location, severity, cause, and message. Although there are no health or redfish alerts for this switch, the structure remains consistent for all tables. Between the time series and tables is the hardware metrics panel, showing real-time data for any metric exceeding health thresholds. Currently, none are unhealthy, but clicking See All Hardware Metrics for this switch opens a dedicated tab with collapsible sections. The admin focuses on the time series visualization and notices multiple link flap events. Hovering over each dot reveals the exact amount of link flaps. Adding all these together totals to 16. They scroll down to the HSN link events table and filter to the HSN link flap detected event. Now that it's filtered, they click the hyperlinked port to open the link detailed view for a deeper analysis. After selecting the problem port, the system administrator is redirected to the link drill-down view, which provides detailed insights into the selected unhealthy fabric link. This dashboard displays essential information such as port speed, bit error rate, forward error correction per lane, potential causes of link failure shown in this time series visualization, and a table of link error data along with recommended troubleshooting actions. The time series visualization highlights possible reasons for the link failure, with each cause color-coded for clarity. Both BER and FEC values should remain low. Low BER indicates a high-quality link with minimal errors, ensuring reliable data transmission, while low FEC means fewer corrections are needed, suggesting a stable connection. Conversely, high BER signals poor link quality and potential data loss, while high FEC suggests the link is compensating for numerous errors, which could lead to failure if unresolved. These metrics together help diagnose link issues and guide corrective actions. At the bottom of the view is a HSN link events table summarizing link errors, including event type, severity, timestamp, cause, and recommended actions, helping the admin quickly locate and address issues. Another table, link-related fabric health events, lists alerts with their category, severity, cause, and suggested fixes. For this link, there were no link-related fabric health events that took place. The most critical element here is the recommended actions panel located between the FEC details and the time series graph. Clicking this panel reveals step-by-step troubleshooting instructions. Relating to our use case, the system admin noticed a link flap event occurred thanks to the HSN links event table. They want to resolve this link flap and click the recommended actions panel to access the remediation steps. The recommended actions panel states that the reason for the link being down is because a link flap occurred. The recommended action is to reseat the cable. The system admin can click this panel to be taken to the link troubleshooting procedures view, which lists the recommended actions. Once on the recommended action panel, the system administrator is provided with clear step-by-step instructions that they can follow to verify findings and resolve the link flap issue. If the problem persists after applying these steps, the page conveniently includes customer support contact details for further assistance. By following the recommended actions and implementing the necessary fixes, the system administrator can efficiently remediate the link flap and restore the system to optimal performance. Now that the system administrator has applied the remediation steps, they return back to the switch's detailed view to verify the link status and observe if the link is now up. After reviewing the switch port display, they notice all links are green, healthy, and functioning properly. Now that we've wrapped up use case 1, the Monday morning sweep to troubleshoot link flap issues and monitor fabric health, what did we learn? With HPE Slingshot monitoring software, the system administrator can monitor fabric health in real time without relying on the CLI. They can quickly surface link flap issues by drilling into switch detail to review time series telemetry, use the show all metrics feature to correlate symptoms with root causes, and then dive deeper into the link detailed view to visualize problem ports. From there, Slingshot monitoring software provides automated recommended actions to resolve issues and make it easy to validate fixes.